Okay, so the question states that lines A and B and lines B and C are parallel, which is, in this case, our given. Now, if these are parallel, we know that angles 4 and angle 5 are supplementary because they sit on this straight angle here and they share a common vertex and a common ray. We know that by the definition of linear pairs. Now, the measure of angle 5 has to be equal to the sum of the measure of angle 2 and the measure of angle 3. Now, that might seem a little strange, but if we cut this transversal out and pretend it isn't here for right now, we see that all of these are congruent by the definition of alternate exterior angles. Also by the definition of alternate exterior angles, we can conclude that the measure of angle 3 and the measure of angle 6 are congruent. We know this because they are on opposite sides of the transversal but still stay within the boundaries of the parallel lines. Now, if we know that the measure of angle 5 is equal to the sum of the measure of angle 2 and angle 3, and that the measure of angle 3 is congruent to the measure of angle 6, we can just substitute 6 in for 3 and know that the measure of angle 5 is equal to the measure of angle 2 plus the measure of angle 6. We get this by substitution. Now, going back to our above statement, the angle 4 and angle 5 are supplementary, or 180 degrees. We can substitute it in to know that the measure of angle 5 plus the measure of angle 2 plus the measure of angle 6 is all equal to 180. So that is our proof.